The PSE-3000 will arrive at your home already calibrated and configured. After some months you use the PSE-3000, it may be the moment to calibrate it again. This may be the case if by mistake, you crash the nozzles on the nozzles holder numerous times. The procedure is not difficult and I'll try my best to explain it in an easy way to follow. We need to reset the previous calibrations. We do this in openPNP, Issues and Solutions tab. We click the checkbox, Included Solved. We want to reset the homing FIDUCIAL. We will calibrate it again. So in the tab, Machine Setup, we click Reference Head, and we set the homing method to None. Do not forget to click on Apply every time you make a change in the settings. In the Issue and Solution tab, the visual homing problem does not appear. It is because we need to refresh the tab clicking on Find Issues and Solutions. Here it is. Now we reset some of the solved issues. Done. It may not be necessary, but here I check the serial ports. I use Device Manager. Then I'll make the configurations in openPNP. Do not forget to click on Apply, otherwise the settings are not stored. We need to set the cameras. If they do not appear in the list, power off the PSE-3000, disconnect the USB cable, then power on the machine and connect the USB cable. It is important to set the properties the same as the default values. We repeat the procedure for the bottom camera. It is the moment to calibrate the visual homing. Here we see the procedure assuming the visual system is already properly set. To calibrate the visual system, I'll prepare another video. Depending where the head is, it may be necessary to disable the soft limits. In the Issues and Solutions tab, clicking on Enable Visual Homing, I can read the instructions. I need to jog the top camera over the fiducial pivot. Then manually I set a good feature diameter that allows the visual system to lock the viewfinder on the pivot. Clicking on Accept, the homing procedure starts. When the home icon turns from yellow to black, it means the homing procedure was successful and the new values are stored. All the coordinates will refer to the homing fiducial. Now we can read Solved. Let's follow the procedure for the primary fiducial. We can read the instructions here. The primary fiducial allows the PSE-3000 to know where the top camera is located in relation to the working plane. Also, this issue is marked as solved. In the tab Machine Setup, clicking on Reference Head, I can read the values set for the primary fiducial, as well as the new values for the homing fiducial. Here you can also set the park location. For the primary fiducial, it is missing the Z value. It will be automatically set when we will calibrate the nozzle N1 offset. Now it is the moment to set the soft limits. We enable them, and we check if they are okay. I need to move the head till it arrives about 5 to 7 millimeters from the end of the rail. In the case of the Y-low soft limit, it was set too far. I will fix it. Well done. Now I calibrate the backlash compensation for the y-axis. It reduces the effect of any looseness. To the end of the calibration, a compensation method is automatically set. You may repeat the procedure also for the x-axis. It is paramount that you set the soft limits before to make the backlash compensation. After the backlash compensation is completed, I recalibrate the primary fiducial. Okay. We need to load 2 nozzles. It is very important that we set the tool changer to manual, because we still didn't set the position of the nozzles on the nozzles holder. So, if we keep on automatic, the head will crash on the nozzles holder. Do not forget to click on Apply. Here you can also set the manual change location. I select the nozzle N1, and in the Nozzle Tips tab, I select the nozzle tip 504. Immediately the head will move to the change location for nozzle N1. For nozzle N2, I select the tip 504B. Now we want to set the nozzle N1 and N2 offset for the primary fiducial. I read the instructions in the Issue and Solutions tab, and I proceed. But actually they should have been named it the offset between the top camera and the nozzles. After the offset is calibrated, every time the viewfinder is over a point, you can put the nozzles over it. Thanks to the primary fiducial, the PSE-3000 will be able to understand how far the nozzles are in relation to the camera. I move the nozzle N1 over the primary fiducial and I lower the tip till it touches the board. I'll check with a magnifier, and when the tip touches in the precise center, I click on Accept. I repeat the procedure for N2. In this case, I cannot see the line for the N2 offset. It is probably a small bug. I click on Include Dismissed, and it appears. I park Z and XY. Now I can test the primary fiducial for N1 and N2. Then I click on this icon. The last used nozzle will go on the primary fiducial. Very well, I could hear the tip touching the board. Let's select N1 as target now, and we repeat the operation. Very well. But there is something to know. Every time a tip is changed automatically, taking it from the tips holder, the Z position is reset with a value stored in the script homez.g. We need to launch a Z reset to check if the value is correct. We can do it by the Actuators tab. Home Z. When I click on, the Z position is reset. Let's check if the Z distance is correct. Let's try with N1. I heard touching the board, but we need to check if it went passing the first touch. Yes, it seems it went further, 0.2 of a millimeter. There is a spring, so it is not a problem. But if N1 went 0.2 millimeters farther, N2 will be 0.2 shorter. Let's check. Indeed, I didn't hear any touching. Let's move the tip down by increment of 0.1. Yes, I heard it touching after 0.2 millimeters. So we need to change this value in the script. We need to enable the Wi-Fi to use DWC. In our channel, there is a video explaining how to connect and use DWC in detail. Please check. Here we see the steps. We disconnect the machine by the red power button because we need the serial port. I check again the serial port number for RepRap firmware. It is COM12. In our folder, there is Termite. I launch it and I set COM12 for the communication. I open the file codify.txt. It contains codes and instructions to enable the Wi-Fi and obtain an IP address that allows us to connect to DUET Web Control. After inputting M552S1, I need to wait a few seconds and the IP value will be given. Now I use this IP in a browser and I can connect to DWC. I go on the system and I click on homez.g. I need to change the G92 value for Z. It is 14.5. We need to decrease this value by 0.2 millimeters. The new value will be 14.3, then I save the file. Now I need to power off the PSE-3000 and power it on again. I need to perform a visual homing again. Then I reset the Z position by the actuator. Now I move N1 on the primary fiducial. Okay, I heard it touching. Now N2. Also this touched. Perfect. We now calibrate the secondary fiducial. Its purpose is to understand the parallax of the camera in relation to the nozzle. It gives to the PSE-3000 an understanding of the 3D space, not only the 2D working plane. For this reason, the secondary fiducial needs to be at a different height. In our folder, there is a PDF you can print to have a target. The height of the object that you will use needs to be about 1 centimeter. I used a blades package. In the Issues and Solutions tab, I read how to operate, and then I proceed.
Okay.
As long as the red circle is centered on the target, it is okay. Done. Now, I need to calibrate the offset from the camera to nozzle N1 for the secondary fiducial. Again, in the Issues and Solutions tab I read how to operate, then I proceed. Well done. It is the moment to calibrate the bottom camera. By doing this, the PSE-3000 will understand its position and the better focus distance from the nozzle tip. I've read that I need the smallest tip. For us, it is the 502. The tips should be cleaned before being used. However, I change the tip and I move N1 over the bottom camera.
P.
The green circle means the tip is locked in target. Now the tip is moved slowly up and down to determine the best focus distance. Okay. We could calibrate even a more precise offset between camera and nozzles. This takes into account also the runout of the nozzle. The runout is an imprecise concentricity between axis of rotation and actual position of the tip, eccentricity. This will be calibrated even further with the nozzle tips calibration. Inside our small toolbox, we have some paper discs. We will use one of these with the white side facing up. A badly executed procedure is far worse than not doing a precise nozzle calibration. What can go wrong, for example, is that when the disc is positioned on the board, the nozzle lifting up can move it, messing the entire calibration. For this reason, I use a little bit of grease, so when the disc is placed on the board, it will stick till the next lift up. But pay attention, too much grease will result in the disc not being able to be lifted up. In this case, the procedure will be stopped with the message, "Target not found." We position the disc a little far from the center of the fiducial. We read the instruction in the tab. We set a good feature diameter, and we click on Accept. Monitor the entire procedure. Also, this is marked as solved. Now we need to check the results by putting the two tips on the primary fiducial. Very well. I park the Z. Now let's check how many issues are still open. These should not be here. I remember I already set the soft limits. We need just to refresh the list clicking on this button. Okay. About the cameras, I want to point out that if you want, you can increase the FPS for the preview. This is only useful for you. It is not used by the system. I'm using a 17-year-old notebook, so I keep it low. Here there are also other settings. For example, you can set to keep the light always on or to switch off after capture. We are at a good point. We still need to calibrate all the nozzle tips and to set the automatic nozzle tips change system. But now we test the precision of the system so far. We load a job and we test the pad's targeting. Please refer to the video Quick Start if you have doubts about loading a job. We see if the board origin is right, clicking on this icon. It needs to be fixed. Okay, now I acquire this location by clicking on this icon. We probably need to fix the Z value. To check the actual value of the board, I can go to check the primary fiducial. It is written minus 12.5. We add 0.1 for a good contact. So the new value is negative 12.6 millimeters. Now to fix rotation and position of the board, I perform a fiducial check. Refer to the video Quick Start for more details. Okay, Position and rotation are updated. Let's check on some pads. I select our 242. Position the camera at the placement location. The viewfinder shows a perfect positioning. This means the coordinate system is well set and the vision system did a good job recognizing the right position and rotation of the board. We try with the next components on the list. Very well. Now let's try to position a nozzle over the pad. Okay, let's do the same for N2. Okay. Let's start the nozzle tips calibration. This check for eccentricity in the tips. There is also the possibility to calibrate the bare nozzle. This may be done when after calibrating the tips, there is still a consistent error. This could be probably being caused by an eccentricity of the bare pipe. I added a tip called unloaded. The procedure should be done on this. A video about how to calibrate the bare nozzle will be made soon. The tip 504 is already loaded on N1, so I start with this tip. The tips need to be cleaned before the calibration. I forgot to do it. Let's see. The target of the calibration must be the hole and not the external circumference. The tip is dirty. However, the calibration was successful, and here you can read some values. For example, the runout is 0.12 millimeters. Let's try cleaning the tip. I use alcohol and a needle. We load the nozzle and we calibrate again. It was much cleaner. Okay, we repeat the procedure for tip 504B. We repeat the procedure for tip 502. We load on N1. We clean the 502. Calibration. Perfect. We proceed with the other tips. Done. Now, I need to remove the tips from the nozzles because I need to set the positions of the tips holder. We will set the automatic tips changer system. It is very important to start with the loaded list empty and no tips on the nozzles. First step is to change the tool changer to automatic for both the nozzles. Do not forget to click on Apply. The system uses 4 locations. The first put the nozzle support in front of the nozzle tip. The second puts the nozzle support on top of the nozzle tips. The third gets the nozzle tip inside the support. The fourth extracts the nozzle tip. Refer to the video quick start if you have some doubts. The Z position must be set to prevent the tip already loaded in the other nozzle crashing the holder. We check the positions. As we see, we need to correct the position. We set 0.1 mm in the jog control, and we move the head to correct the Y alignment. We do the same if we need to correct the X alignment. Now we try to go down by 1 mm. It seems the head needs to be moved on the right a little. We fix the X alignment by 0.1 millimeters. Then I change the steps to 1 millimeter and I start to go down. I check if the tip is free to move. If it is not, it means it is forced against the holder because the alignment is not good. Then I change again to 0.1 steps and I go down checking if the tip is free to move. It doesn't have to go all the way down. Minus 15.4 millimeters is okay for this tip. Now we need to update some fields. We are in the third position. I acquire the position of the nozzle clicking on this icon. Apply. The X value for the third position is the right value for all the positions. So I copy it and paste in the other positions. The Z value for the first and second position is the right one to avoid the tip already loaded in the other nozzle crashing the holder. The Y value for the third position is the right value also for the second position. So I copy it and paste it. The Z value for the third position is the correct one also for the fourth position. So I copy it and paste it. Now I check the first and the second position, and I go down by 1 millimeter steps. Okay. Now we try to load the nozzle automatically. Okay. Unload. Perfect. Nozzle N2 cannot load the first tip. I move the head in the first position and I move it 2 centimeters on the right, because the first position of the second tip, 503, is just 2 centimeters on the right. I select the tip 503, I acquire the nozzle first position and I click on Apply. Now I can copy some values from the previously set 502 tip. The Y value for the second and third position is more or less the same. Copy from 502 and paste in 503. Then, as before, the X value for the first position is the same as the X value for the second, third, and fourth position. However, some small adjustments will probably be needed. The Z value of tip 502 for the third and fourth position is very close to the Z value of tip 503 for the same position, so I copy it and paste it. Now I need to verify. I go to the second position, and I check the X and Y alignment, then I go down by 1 mm steps. It seems it touches on the right, so I correct it by moving right 0.2 millimeters. Let's test again. Okay, some values have changed, so I need to acquire these values for the third position and make the corrections for the other positions. Okay, let's try to load the tip 503 automatically using N1. Perfect. Now we can try loading the tip 503 with nozzle N2. Now I repeat the same procedure for the remaining tips. On the market, there are machines a little cheaper that look the same as the PSE-3000. They are not. Only the frame is the same. Firmware, guide rails, nozzle tips, and stepper motors are not the same. People who bought those machines are continuously sending me emails asking for help. Sorry, I will not provide help for machines that are not made by PickSoEasy. We also produce manual and semi-automatic pick-and-place machines. Please check on our website. New tutorial videos will be made soon.